So in the second tutorial in my sequence of FTC Java tutorials, I'm going to show the basic way to add capabilities into an empty op mode. And this is going to be a fairly standard approach, and then after that I'm going to show a more efficient approach of doing the same thing, but instead of just adding code in line to the op mode, I'm going to show using a hardware class that tries to encapsulate the various devices that you use on your robot. So to get started, we're just going to pick up where we left off in the last tutorial, which is the My First OpMode that we built. And if you haven't done the first tutorial, I recommend you go back and just follow along and create it, and it'll show you the whole copy-paste process of how we got to here. A couple of simple steps, but they're important steps. Anyway, so on the left we see the My OpMode that was just created from the template, and on the right we actually have the code. So in order to actually start doing something with the motors, because the current code just puts stuff on the this display, it doesn't actually do anything. All I'm going to do is go through and uncomment some of the example code that's left in there, and you'll see what's the basic approach. So the first thing we always do is we always create some objects for the various devices that we are going to be accessing. In this case, I've got a couple of motors, DC motors, and they're called left motor and right motor. So that's done right at the beginning of the class, and then once we move down into the actual run op mode method, which is what's called when the program starts, we're going to do a little bit of the initialization. We can only do this once the op mode is started, because if we try and do it first thing, it's too early in the process, and the hardware may not be available. So in the run op mode, I'm going to uncomment these lines here, and this is where we are attaching to the hardware. So we assume that there's a hardware device that's been configured on the robot called left motor, and so then we are creating a object. We already created the object up here, but we're getting a handle to the motor and putting it into the object, so we're getting access to those objects here. Then typically on any robot you're going to want to reverse at least one of the drive motors, just because the motors are facing in opposite directions, and in this case I'm assuming that I want to reverse the right motor. This will depend on what brand of motor you're using and whether you're putting any gear reduction or track drives in on your motor, because gear reduction and some motors run in the opposite direction. So this is something that I always recommend you test. You plug a motor in to a battery, see which way it runs. If it runs forward, then leave it set to forward. If it runs in reverse, then set the direction to reverse, and that way when you give positive power to both motors, the robot will drive forward. Then the last thing to do is process the code that's going to run each time we go around the loop. This is our main driving loop. It's got the while is op mode active, and when we're in here we're going to basically do a tank drive, which takes the left joystick the left joystick y-axis, which is forward and back, and feeds it directly into the motor power. Notice that we're putting a minus sign in front of these, and that's because when you push the joystick forward it gives you a negative value, which I know is crazy, but that's how all joysticks are. And the last thing, we have the idle. So this code here will enable us to do basic tank driving. So that's a fairly classic way to build the op mode. So if I have a look, my ZTE is here, I'm going to hit the run, and it should build it and then deploy it and then execute it. Installing. And launching. Now I'm going to show you a slightly more efficient way to create op modes, and this is really for when you have larger vehicles and when you're doing multiple op modes. As you can imagine, the more devices you start having on your robot, the more variables you need to initialize, that you need to assign the names to them, you need to configure them, and if you have to do that every time you create an op mode, it gets kind of cumbersome. So the way around this is to create a hardware class that does all the robot hardware configuration, and then you just use that, you just reference that inside your op modes. There's a really good example. Actually, most of the examples in the sample section are built this way. So if we go to the pushbot teleop POV linear sample, And to decode this means it's built for the pushbot hardware. It's the teleop program. It's using POV, control point of view driver style, which means that the left stick forward and back moves the robot forward and back, and the right stick right and left turns the robot. And then it's a linear mode, as most of the examples are in here are linear modes. So as usual, we're going to copy this, and we're going to go down into the user code here, and we're going to paste this here, and it's going to ask us a name. So I'm going to give it a name that works for me, and ultimately we're going to be creating a FillBot here. So FillBot teleop. Oh, not a legal Java name. And this is because this is the class name, so I cannot have spaces, and I should have capital letter there. Okay, and you see it gave me the OpMode here, and it created it for me and popped up the window. I'm going to shut down the other one just to get it off my tab. So, as with all cases where we create new OpModes, it's always good to put a new name on here. So I'm going to put FillBot teleop, and this is what's going to appear on the driver station screen, so it doesn't have any fancy formatting requirements. And I'm going to make this a fill group so that it sorts separately from everybody else's. And I'm going to comment out the disable, so this is now an active OpMode. So these two OpModes both have their disable commented out, so they're both active. Now the key thing you'll notice on this OpMode is that unlike the other one, there's not a whole lot of declaring of hardware variables and initializing them. This part of the code is very streamlined, and that's because we're using this hardware pushbot class. We're declaring this member called robot, and we're initializing it. And what this is doing is saying, well, all that initialization is done somewhere else, and I'm just sharing it. So where is it done? Well, hardware pushbot is part of our sample folder up here, hardware pushbot. Now, although we are creating an OpMode in our team folder and we're doing all this editing, for the time being we don't have to copy out the hardware pushbot unless we're going to change it. In this case we're not going to change it, so I'm just going to leave it, reference it over there, but I'm going to open it up and just show what's inside it. We'll get around to creating our own one a little bit later. So I'm going to open up the hardware pushbot, and in the hardware pushbot it looks a lot like what we had in the old class structure. We're declaring our motors and servo objects, we are declaring some constants, a couple of variables, and then we have this new function that's added in here called init, which does all that setup for us. So this is exactly the same as what we would have put in the OpMode, but now it's in the init for the hardware class. It's setting the powers, it's setting the run mode, and it's setting the servos and enabling everything. So this is everything that a basic off-the-shelf pushbot might want in terms of hardware. And so that's all done, so you don't need to worry about it. So if you were just doing a whole bunch of OpModes for a pushbot, you wouldn't even need to declare all that stuff. So then looking forward into the actual teleop program that's using that hardware, the difference here is whenever you want to access variables related to the hardware, you have to prefix it with this robot name here. So for example, I'm just going to change this telemetry to say hello Philip, so I know it's changed. But now the way this OpMode is set up to do several things. It's set up to drive in this POV mode and manipulate the arm and the grippers. But let's just look at the code for driving for a second. So because it's using the POV, this means that we're going to use the left stick Y, which is the forward and back on the left stick, and we're going to feed that to both the left and the right wheels. But we're also going to use the right stick X, which is the left and right movement on the right stick, and we're going to add it to the left drive and subtract it from the right drive, which means that as we move the stick to the right, it will increase the power on the left wheel and decrease it on the right wheel, which will cause it to turn to the right. So that's what's happening here. So I'm setting up these two variables, left and right. Then I do a little bit of math here to normalize the values. And what that means is when you do this calculation here, it's possible that the left or the right value may end up with a number that's bigger than +1 or smaller than -1, less negative. So to do that, what we do is we do a test to see what the maximum value of those two variables are. So in this case, we take the absolute value of the right and the left and find the max. and that'll tell us whether any of those numbers, either of them, are greater than 0.1. And if they are, what we do is we divide both numbers by that max value. And what that does is it gives us a maximum value of 1 on one of them, and then a scaled back value on the other. If you just run through some examples here, you can see what will happen. But this is a fairly nice way to get some reliable turning without swamping the motors with full power when you don't want it. This could be totally left out. It's not necessary, but it's just a nice driving technique. And then the last thing we do with the motors is we take these left and right powers and we set the power on the motor. But you'll notice we have to prefix it with robot. So it's robot.leftMotor.setPower, because this left motor object is actually part of the robot object. So all this part here is driving, and then we do a bunch of stuff down here for manipulating the servos. We have two claw servos, a left and a right servo, and we need to open and close them together in opposite directions, and that's what this code here is doing. It's coming up with an offset from center, and then it's letting us increase or decrease that offset, and then apply it to the center position of the servo. So that's what's happening here. And then this piece of code here is taking the up and down buttons, the Y and the A, and checking to see whether it needs to move the arm up or down. So it's saying if the Y button is being pressed, then set the arm motor power to this value that is robot.armUpPower. And this is a constant, or a final in Java, that is just a number that represents how much power we want to put when we go up, likewise down. Instead of just putting the numbers in here, setting up these constants is always better, because it means that you can change it. If you ever want to change one of these numbers, you can change it in just one place. That would be in the hardware class. And it also is meaningful. When you see this number, you know what it means. Oh, that's the power that I want to apply when I'm going down. And then last, we send some telemetry data to display what our offset is and what our left and right motors are doing. So this format of having a hardware class and then an op mode is not that much different than the regular one, but in the end it'll save you a lot of grief. So let's just build this and verify that it all downloads, and we'll just see how it runs. Click on the run. Installing, and then it will run it. So it's launching the activity. It's connected. I'm going to select op mode. You see there's the my op mode, the original one, and then the fill tally up. Something that I must note here is that all of these samples are built using a predefined set of device names. And if you want to see what those names are, if you go to the sample conventions file down here, open it up and scroll down, these are the names that are assumed for the various devices on the robot. Some of these are for sensors, some of these are for motors. So if you want to run these op modes, you need to set up at least these names on the devices you want to control. So in the case of this example, you need the left-right motor, the arm motor set up, and then you need a left claw and a right claw. And if you set those up on your motors and servos, then this example will run without errors. If you don't have these set up, you will get an exception saying it can't find that device name. If you set these up but you don't have the hardware attached, it'll give you warnings. You'll still be able to run the program, but it will have a big red warning saying, hey, right now I can't see these devices. I know they're meant to be here. But that's a thing to keep in mind when you run these. And then launching. So right now this phone is configured with hardware that isn't plugged in, so it's giving me a warning, but it is only a warning. So now if I find my op modes, hello, FillBot tally up. If I scroll up past this warning, you'll see the messages. So if I knit it, it says hello Philip. And if I play, oops, I stopped it. Play, and I have a joystick set up so I can initialize it. I'm going to come down in here so we can see this, and then I can push my left stick forward so the left and right motors are both going 1 backwards, and if I turn right, the left is going 1 and the right is going -1, and then combinations in between, and then I can also change my draw offset. Alright. So the last thing I want to do here is show how you can extend this for your own robot design. So in this case we have the hardware pushbot, which really knows what's on a pushbot robot. But obviously when you start building your own robot, you're going to start adding more hardware, more motors, more servos, sensors, stuff like that. So you really can't use the pushbot hardware class anymore, but the logical thing to do is then create your own. So as in all cases, we're going to take a copy of the one in the samples, put it into our team project, and then edit it. So in this case, I'm going to take hardware pushbot. I'm going to right-click and say copy. I'm going to go down to my team code. I'm going to right-click and say paste. And it's going to ask us for a new name. And I'm going to make this hardware FillBot. All right. So I'm going to get rid of hardware pushbot and just leave these two up. So right now this is now my hardware class for my robot, and I'm going to obviously change the comments because I want it to be correct. So let's assume for the sake of the argument that my first thing my robot's going to have that I add on top of what a standard pushbot has got is a turntable, so I can move my manipulator around. So this is going to require another motor. I'm just going to copy and paste this. And so this is going to be my turntable motor. And I'm going to call this table motor. So that's going to be the device name. And so now I need to add one of everything. So I'm going to add one DC motor, and I'm going to call this table motor. And because I am really funny about things lining up, I'm going to do that. Then I'm going to come down here and just make a note of the fact that this is gray here. Tells me I'm not using it anywhere yet. So it's my indication that, hey, something's up. Likewise, my arm up power is not being used anywhere either, which is kind of interesting. Okay, so I'm going down here, and so I also need to get a handle on this motor. So I'm going to be table motor, and it's going to look for a device called table motor. Oh, LE, table motor. And let's assume that this one has to run in reverse. I strongly recommend that when you set up your drives and your motors and stuff, you come up with a convention for what you think positive should mean. In the case of a drivetrain, positive should mean forward. On an arm, you might decide, on the turntable, you might decide, well, I'm going to assume that positive, if I give positive power to the motor, it's going to turn clockwise or to the right. And once you make that convention in your head, you can test it. You can say, okay, let's plug a motor straight into the battery, see which way it turns, and if it's turning the wrong direction, change the forward and the reverse here, so that you know that if you give it a positive power, it's going to turn in the direction you expect it to. It's always better to know that ahead of time rather than have to guess it and then fiddle it out later. I also want to make sure all my motors are turned off. Some of these things where I'm turning things off or setting them aren't strictly necessary because that's the default. But if you don't know what the default is, or if you can't rely on it, then you really should set it yourself. Now in this case, I'm going to assume that my table motor has got an encoder on it because I want to be able to control its speed really closely. And so I need a different constant here. In all these cases, you can hit the period, and then it'll give you the options, run using encoders. And then I'm done. Okay, so right now I've got this new FillBot hardware class, which is really cool, but it's not being used anywhere. So if I go back to my FillBot teleop here, I can go up to where it says what hardware it's going to use. In this case, hardware pushbot. I can just change both of these pushbots to FillBot, and it will instantly start using the new class. So now these two pieces of code are independent now from the samples. You've got your FillBot teleop and the hardware FillBot, and they are now working together. So for example, if I wanted to control the rotation of the turntable with the gamepad, it's kind of like the up and down arm. So I'm just going to copy that whole section of code. I'm going to change my comment to reflect the correct directions. Move left when I hit the X key. Yes, that's the X key. And right when I hit the B key. And then I can go in here and change this to X, this to B. And then all that's left here that's a little bit weird is that this setting the power to these values that are arm up power and arm down power, which aren't really relevant because the power that you want to use on your arm is not really the same as the power you may want to use on the turntable. For example, you may want, if it's really geared down a lot, you may want it to go full speed. These are in the robot object. So I'm going to go back up to hardware FillBot, and I'm going to add a couple more constants or finals. And I'm going to call this table left power, table right power, and we decided already that left is going to be my negative direction, so let's make this minus 1.0 and right. Alright, table left power, table right power. Currently they're grey because they're not being used. But if I go down to here, and once again I can just delete this stuff here, hit the period, and it will prompt me. And if I can't see it, I can just start typing. Table left power, table right power. And there we go. And I could choose to display some more stuff if I wanted to, but basically this is just it. So you can see how the process was there. I created my own copy of the hardware class. I added in my devices in the hardware class, and then I changed the actual OpMode to use that hardware class. So now if I want to create another OpMode that's one of my special ones for this robot, I can just do a copy and paste on the FillBot teleop, or I could bring in any other example and just tell it to use the FillBot hardware instead of the PushBot hardware. So it's a pretty standard process, and I hope it made sense for you.